Welcome and good day. We started a course on regression data analysis, so I want to talk about the concluding part of regression analysis, and that is the residuals. The residuals show you how far the actual data points are from the predicted data points using the equation. For example, from the table, the first data shows quantity sold as 8,500 when the price was fixed at 2 naira and advertisement was done at 2,800. Let me show you the table. So this is a table. So you can see here that when we had a price of 2,000 and advertisement of 2,800 was done, we got 8,500 naira as our sale price. So don't forget that we said this is the dependent variable and this is the independent variable. What we're trying to know is what is the contribution of this independent variable to this quantity, or if you like, the high quantity prices that were sold. So here we've done our prediction, we've gotten our formula, so we want to see how far we are from the actual data point. So based on this data, using the equation, the regressional line is y is equal to quantity sold, which is 8536.214 minus 835.722 times price plus 0.592 times advertisement. So if you fix in all these values, if you're fixing the value of price as 2 naira 2 and advertisement as 2008, what you will have is 8523.009. So but the actual amount we got as our selling price, which is this, so the actual amount we got as our selling price was 8,500. So what is the difference? So this is now our predicted price based on the equation that we have. So the difference is minus 23.00896,712. So that's how you can find the same residual for all the others. So once you can use this, is showing that you can use regressional data analysis to predict what will happen when your dependent variable prices are adjusted. So the next one I'm going to talk about, so the graph now shows how this is. So you can see from this graph here, so the area we are selecting here is from A35 to C42. So if you plot this graph, this is exactly what you find. So that's how you can use regressional analysis for your prediction. So I'm going to talk about another part of AI, artificial intelligence, which is found in Excel. It is called the flash field. So what the flash field does is that it recognizes a pattern in the data and it can use that pattern to fill any remaining gaps that you have. So once the pattern has been recognized, you can fill the other cells by using a flash fill. You go to data menu and you click on flash fill, or you type Ctrl E. So let's see how using this example, this is a table that we have. This table has first name, it has last name, and it has email addresses. So we want to use flash fill to retrieve the emails, the domain name for all these emails. Don't forget that when you write your email, the other part after this @ sign is normally the domain name. For example, the domain name for this first email is multiple.com. The domain name for the second email is mappy.co. CY, and the rest of them up to the last one, which is typepad.com. So we have a domain column here, so we want to automatically retrieve this domain name and fill them here without having to do that manually. So what I'm going to do is I will enter the first one, multiply.com. Then I will enter the second one, map.p.cv. What have you noticed there? What you've noticed is that as I'm typing the second one, map.p.cz, so I'm typing the second one, then I can now go to data menu. So I'm moving to data menu. And from data menu, I will look for flash fill. So I'll click on flash fill. So immediately I click on flash fill, you notice that the system automatically recognizes the pattern and fills this other one for me. So either I click on flash fill or I use Ctrl E, and that will be filled. So the emails have already automatically been recognized and picked. So imagine if you're having thousands of data, you just type the first two, pattern is recognized, click on flash fill, then all the others will be retrieved. Now that's a case where you have this. So let's look at a case where these variables are mixed with prices, with the amount in dollars. So we want to retrieve only the amount. What do you do? The same way. This time around, instead of using flash fill, I'm going to use Ctrl E. So I'll type the $ sign and I'll type 500. So I want here the same thing. I'll type the $ sign, I'll type 507. So once I do that and I click on the other cells, I will just do Ctrl E. So immediately I type Ctrl E, the system automatically fixes all this for me. So that's what flash fill does. So it's an artificial intelligence. What is an artificial intelligence? It's a way of recognizing pattern. And once you recognize pattern, then you can make prediction. So now it recognizes the pattern of what I want and automatically autofills the other values based on what I have in mind. Then I'll go to correlation. So in correlation, we want to find out how related are the values that you have. So we have here a table with X and Y column, and the values are here for X and this is for Y. We have another table X and Y, the values are here for X and the values for Y are listed. Then we have A, B and C. The values for A is listed, the value for B is listed, and the values for C is listed here. So now we want to know how related are these values to each other. So the first thing we'll do will be to plot a graph for this. So if I highlight the whole of this from here to here, and I go to insert, then I go to chart, so I pick any of my chart type, 2D, then I can pick lines, and I click OK. The system will automatically return this for me. If I highlight this one, go to insert and bring my chart, it will bring out this for me. If I do the same thing for this, it will bring this out for me. So now using this variable X and Y, how related are they? Looking at the graph that we see. So on the second table, X and Y, how related are they? And looking at this again, how related are these two? So if looking at it just by mere looking at it, you can see that X and Y are very related here because they rise. As they're rising, they rise together. When they fall together. They rise again and they fall together. But you can see this is different. As this one is moving in direction, is open. So these are two different people moving in opposite direction. They are not related at all. This is just visual, looking at it physically. And if you look at this again, what you see is that between A, B, and C, which one is related? So looking at their legend, their color, you can see that A is related to C because A rises with C, falls, and rises again and falls, but it's totally different from B. So now let's use the real statistics formulas to see how this is done. So here for correlation, there's a formula. The formula to use is Corel. So if you want to see the relationship between A2, colon F6, yes, and B2 colon B6. So you use this formula is equal to curl A2 colon A2, that's the range, comma B2 colon B6. That's what I applied here. So once you do this, the system returns the value 1. So if you do the same for the second one, that is between this and this, the system returns this value -1. So you can see here that these two are not related at all. So let's read the correlation coefficient, a value between -1 and +1 tells you how strongly two variables are related to each other. You can use the curl function to or analysis toolbar add-on in Excel to find correlation between two variables. The correlation coefficient of +1 indicates a perfect positive correlation. As variable x increases, variable y increases. As variable y decreases, variable y will decrease. So if you're working with two different functions or two different variables, you can automatically use this formula to get it done. But in the third case here, where you have three different variables, how do you do that? So you have to use the inbuilt data analysis correlation built function to get this done, especially when you have more than three variables. So what do? You go to data, then you see data analysis. So click on it. Once you click on it, you look for correlation. When you click on correlation, it will now open here. So here you have to specify the range. So what is the range? So I'm going to start from, so the range is from J1 to L6. That's what we have here. So click here and select that range, Then the next thing is group by columns. Then you have to indicate the label. If you indicate the label, the A, B, C column heading will appear. Then where do you want to put this, the output of what you want to do? So you click here. I click on this spot. This spot is J24. So immediately you click and you click OK. The system automatically builds this for you. It automatically builds this table for you. So it's telling you that on the top here you have ABC and on this side you have ABC. So it wants to show you the relationship between them. So how close are these? So look for how close are these. So let's explain what this table means. Variable A and variable C are positively correlated because the value is 0.91. So we're looking at variable A here and variable C. So A to C are positively correlated. So you can see A to A is 1, so that's A on its own, A variable. So on their own, A to A, B to B, C to B are correlated on their own, but we want to see the relationship with others. So now you have A to B. A to B is 0.19. That is far from 1. So what that means is that A and B are not correlated at all. But A to C is quite close. It's 0.9, which is approximately 1. So because A to C is relatively closer to 1, therefore it is positively correlated. So the conclusion is that variable A and C are positively correlated because of this value, but A and B are not correlated at all. Then B and C are not correlated because the value 2 is far below 1. So you can verify this conclusion by looking at the graph. So the graph explains that. So you can see the graph and you can see the differences. So that's how you can find the correlation between the variables that you have. Then let's look at the analysis of variables ANOVA. Now, if you have this example teaches you how to perform a single factor ANOVA, analysis of variable, in Excel. A single factor or one-way ANOVA is used to test the null hypothesis that the means of several populations are equal. So what does this means? Means is the average of a data set found by adding all the numbers together and divided by the sum of the numbers by dividing the sum of the numbers by the number of numbers. That's how you find mean. So in the table shows the salaries of people who have a degree in economics, medicine, and history. So these are different people with different salary for economics, people for medicine, and people for history. So we want to find out if the means of these are equal. So that means if we add all these together and divide by the number, are we going to have the same value here? Are we going to have the same value here? So that's what this is all about. So how do you find this? We can use the data analysis inbuilt button to get us done. So if you go to again to data, then you click on data analysis, it will open here. So when it opens, you look for ANOVA single factor. So click on that. Then here the system is asking us to select the range of cells. So don't forget, you must always include label. Once you include label, you find that part of the analysis will now include economics, medicine, and history. So the first thing we'll do is to select the input range. The input range is from here to here. That is from A1 to C10. That's what we have here. So we're grouping by columns. Then we said we need the label. Then you now go straight, leave the alpha at 0.5. Then you now go straight to output range. Where do you want this result to be outputted? So you click here. So you can see as is T2 is okay output. So okay, this was done from a different, but the output is where you. So I had put my output. I brought it down here. So I click on A16. So for this to be T2, what that means is that initially the output was put far away somewhere here. Maybe this is where I put it. I put it around here, T2. Then I now brought it over here. So but choose where you want it to be and indicate it here. Once you do that and click OK, the system will fix this for you. So it is this analysis now that we're going to use to draw our conclusion. The system automatically brings this for you. So here it's telling us that for economics, they count that 9 values in each of them. So it has counted all these. Then the next thing it does is it will sum the total values up. So it automatically sums this up. Then it will now find the average. So if you divide the sum by the count, you have this, and this. So you can see that these averages are not the same. So because of that, we can now draw further analysis from here. So it also creates this table for us. So from this table, we can now use it to draw a conclusion. So you can see that if this F value is greater than F critical, this is F critical, then we reject the null hypothesis. So the null hypothesis is not true. That means the means of that set of variables are not the same. So in this case, 15.196, which is this value, is far greater than this. Therefore, we reject the null hypothesis. This means that the three populations are not equal. At least one of the means is different. So that's how you use the ANOVA to find out if the means of certain variables are equal. So I'm going to show you something on what-if analysis. What-if analysis is found in, if you want to see what-if analysis, go to data, then you find it here, what-if analysis. So what is it? It's a pop-up box that appears there. I'm going to read it. Try out various values for the formulas in your sheet using scenario manager, goal seek, and data table. So you can do a lot from here. So let me just show you one. This is a bookstore. Now the bookstore has total number of books, which is 100, and at a point they have the percentage of the highest price. That means if you consider a book that is 100, then some of these books, then you have two different prices. So you now have a percentage that was sold when the price was a certain highest value. Then you now have, so the remaining percentage was sold when the price was at the lower value. So we want to find the total amount that was gotten here. So don't forget the total number of books is 100. So we now put highest price and lowest price. So when can you sell a book when at the highest price? Maybe when there's a short in demand, price will go up. But when suddenly you have a lot of competition and they say, and there are few demand, then you can drop the price. So when the price was highest, the system tells us that 60 of those books were sold. That 60% of the books were sold when the price was highest. So how do you factor this? So there's a formula So the highest price is equal to C4 times B4. So the total number of books times the percentage sold gave us 60. Then of course the difference will be 40. That is 100 minus C7 will give us 40. So here you can see that 60 of the books were sold when the price was highest, and 40 is the remaining one that was sold when it was low. What are these prices? So we fix the prices here. So these prices are fixed manually. When it was 50 naira, 60 of was sold. When it was 20, 40 was sold. So if you do the mathematics, you find the total the profit sold. So 60 times this should be amount. So let's take this as okay. So let's take total unit profit. This is the unit profit. So if you multiply this times this, you will now have this as the profit for that when it was highest. Then if you have this times this, you now have this as a profit when it was lowest. So if you sum this together, you have that. So now you can see from here that total profit that was made was 3,800. But we can now ask a question: what can we do? Assuming that what if we want to know how many books you need to sell for the highest price to obtain a profit of 4,700? How many of these books can you sell in order to obtain the profit of 4,700? At the price of 3,800, we sold 60% of the book at the highest price and 40% at the lowest price. Now, at what percentage of this book needs to be sold for us to obtain a total profit of 4,700? So we're going to use Excel what if to get this done. So how do you do that? So you can use Excel goal seek feature to find the answer, and to find this you go to data menu, then you click on what if analysis. So I'll show you that data menu. So for example, you click on data menu, then you go to what if analysis, then you pick goal seek. So let's see. So I've showed that. So when you click on goal seek, it opens here. So now working on this table, the system is going to automatically rework this table and give us our value. So working from this table, don't forget this was when it was 3.8. So I'm going to show you something. This table has already been programmed. 100 books at 60% gave us this. Then 100 minus 60 gave us this. Then this times this gave us this. This times this gave us this. And of course this plus this gave us this. So now we want to see how we can get 4,700. So what is the total number of books that we need to sell in order at the highest price to get that amount? So under goal seek, you now have set cell. Which cell do you want to adjust? The cell we want to adjust is cell E23. So E23. So what is cell E23? It's cell E23 is the amount. So we want this amount to change. So we want to adjust this cell from 3800 to 4700. So what do you want to put in there? I want the value to be 4700. You can see that what is we're telling the system is that at this one that gave us 38, we want the value to be this. Then what are we going to change to achieve this? We will change here. We'll change the total number of books. So that cell we're going to change is cell B17. So that's why I specified it here. So don't forget again, what is our set goal? Our set goal is we want to achieve this. Just like in marketing, this year I'm going to make 1 million naira. So 1 million naira becomes your set goal. Then specify the value. 1 million. What do you need to change? You need to give something to be able to get something. So we need to change the total number of sales. So our sales has to increase if we have to get a higher price. So we'll click on this column, adjust this total in order to be able to achieve this. So immediately you click OK, this is what will be the output. The system will work on it and tell me, look, If you want to achieve 4700, the total number of books sold will be increased to 150. So 150 at 60% highest price will give us 90, and of course 100 minus 90 will give us 10. So what that means is that you need to sell 90 books at the highest price of 50 naira unit profit in order to have 2,500. Then of course the remaining book times the unit price of 20 naira profit will give you this. When you add these two together, you have so that's how you can use what if to analyze your data and set a goal, and of course be able to predict what you need to do in order to achieve your goal. Thank you for listening.